in this question, we're given the coordinates of the point A and the coordinates of the point B in terms of some variable k, and we're given the equation of the line that joins points A and B. So we know that y equals minus x plus 3. So if you put a value of x as 1, you should expect the value of y to be 2. And if you put the value of x to be k, you should expect the value of y to be 5. So let's try that. Let's put 5 equals minus k plus 3. So k equals 3 minus 5 equals minus 2. So now, by using the equation of the line, we've managed to find that the point B is actually minus 2, 5. Because minus 2, or negative 2 is 2, and 2 plus 3 is 5. So we know that that answer is correct. The question then goes on to say, find an equation for the perpendicular bisector of AB. So each of these has its own meaning and implication. So perpendicular means at right angles, and bisector means it passes through the midpoint. So we're probably going to have to find the midpoint of AB. So let's just label these points. Let's say A 1, 2, and B, I think we said it was minus 2, 5. Okay, so these are our 2 points, and so AB probably actually looks like that, but it doesn't matter, I've drawn it like that. The perpendicular bisector will have to pass through the midpoint, M, and needs to be obviously at right angles. It needs to be perpendicular. So we need to find the gradient of AB and then invert it to find the gradient of the bisector. So let's plan this out. So 4 steps. Step 1, find midpoint, capital M. Number 2, find the gradient of AB. Step 3, find the gradient of bisector, or let's call it perpendicular. Step number 4, write the equation of the line. So step number 1, how do you find the midpoint? There's a formula for that. So the midpoint is found by adding x1 plus x2, then dividing by 2, then adding y1 plus y2 and dividing by 2. So we know x1, we know x2, we know y1, we know y2, so we can do that really easily. So that's minus 2 plus 1 over 2, 5 plus 2 over 2. So that will give you half and 7 over 2. So we found this point here. Now we need to find the gradient of this line. Now we could find it saying y2, minus y1 divided by x2 minus x1. But we know the equation of the line, don't we? We could just use that. We know the line is y equals negative x plus 3. So we could use that and simply say the gradient is the coefficient of x. So we could say the gradient of AB is simply minus 1, because this is written in the form y equals mx plus c. So m is the coefficient of x, and here it's just minus 1. So we found the midpoint, we found the gradient of AB. Now we need to find the gradient of the perpendicular. So the gradient of the perpendicular will simply be positive 1. So what you do is you flip and you change the sign so that m1 times m2 is equal to minus 1. So because it's negative, you want it to be positive, and 1 over minus 1, minus 1 over minus 1 is equal to 1. So this is our new gradient, the gradient of the perpendicular. Now the final step is simply to write the equation of the line. So you'd say y minus y1. This is the general expression for the equation of a straight line. Y minus y1 equals m x minus x1. And m we've just found. Now x1 and y1 are the coordinates of a point on the line. Remember, we're finding this line here. So the only point we know is the midpoint. And the midpoint we just found there. So you can use the x that you found here for x1 and the y that we found here for y1. And then you just write this out as y minus 7 over 2 equals 1 times x minus 1 over 2. Now there's no point in writing 1 times anything, so I'm going to remove that. The brackets are unnecessary. And I can move that to the other side. So that becomes positive. So my equation looks something like that. Y equals x minus a half plus 3.5. So y equals x plus 3. So that would be the answer to that. That's the equation of the perpendicular bisector. So that's the equation of this perpendicular bisector. The final part of the question asks about another point, C. It lies on the perpendicular bisector, and they want the distance between C and L. So let's take this and see. There is some point on the perpendicular bisector. Let's put it up here. This is C 4, 8. So it's a point on the perpendicular bisector, and they want the shortest distance between C and L. The shortest distance between a point and a line is the perpendicular. So the distance they actually want is this distance here, CM. So the shortest distance between C and L is actually CM. And the equation for the distance between 2 points is y2 minus y1 squared plus x2 minus x1 squared under a square root. So x1, y1 could be this, and x2, y2 could be m. Let's get the coordinates for m. It's 1/2 and 7/2. So I'll just write that here. M is 1/2 7/2. So the distance is the square root of 8 minus 7/2 squared plus 4 minus 1/2 squared. And that gives me square root of 130/2. And because they're asking for the distance to be exact, it means you leave it as a surd. You don't write it as, 5.8, 5.7. You leave it as a surd. So this is the answer that they're asking for. The shortest distance between a point and a line, it's the distance along the perpendicular, because any other distance would be longer. And because you know these coordinates, you can use the formula.